Do you feel constrained by the screen size of your iOS devices? Want to learn how to fit more content into a single view controller? Follow our Scroll View School course, and you'll be able to scroll, zoom, and page through views in your apps with scroll views. Learn to solve common problems like keyboard intrusion, create complicated layouts with multiple nested scroll views, and conquer auto layout challenges. This course is part of our iOS and Swift learning path, which turns complete beginners into professional developers, and it's available now for RayWenderlich.com subscribers. Hey, what's up everybody? I'm Katie.
And I'm Jesse. Welcome to Scroll View School.
Scroll views are all over iOS. The home screen, filled with pages of app icons, is a scroll view. The Settings app lets you scroll through dozens of options because it, too, is a scroll view. If you've taken a look at the App Store lately and seen rows of horizontally scrolling icons stacked in a vertical scrolling view, those are nested scroll views. Web views in Safari are another good example. When there's more content than can fit in a screen, you're probably looking at some type of scroll view. So what is a scroll view? What are they for? Essentially, scroll views allow you to pin a view in place and move around the content inside. That might mean scrolling in one direction, zooming in or out and panning in multiple directions, or paging through multiple entire screens. Scroll views have handy supporting features to do all of that. They can show indicator bars to track your location, hook up to page controls to tell you which page of content you're on, and when the user scrolls past the edge of the content, the scroll view snaps back, letting the user know they've reached the end.
There are two parts to Scroll View School. The first part covers the basics of scroll views. You'll start by building your own DIY scroll view to help you understand the frame and bounds properties of views and how those allow all the scrolling action. You'll build an app that lets you zoom and pan around an image and manually center it on a device. You'll also learn how to use scroll views along with auto layout with an app that scrolls vertically through a page of content. In part 2, you'll learn how to deal with important edge cases when working with scroll views. You'll embed existing layouts in scroll views, nest one scroll view inside another, deal with intrusive keyboards, and more.
As you follow along, be sure to give all of the challenges a try. They'll really help you solidify your understanding and give you practice actually using scroll views. With all of that said, we're ready to get scrolling! To understand how scroll views work, it's helpful to have a solid grasp of frames and bounds. Every view has a frame property. A frame is a CG rect that represents the viewable area of a view in the coordinate system of its superview. If you're not familiar, a CG rect is made up of an origin point, defined by a pair of x and y coordinates, and a size, defined by a width and height. We're just concerned with that origin point right now. In this example, the light gray view represents the view of a view controller and the superview of the cat image. This adorable cat has an origin point at 50-50 in that superview's coordinate space. Notice that the y value increases as the view moves down. Views also have a bounds property. Bounds is also a CG rect, but it represents the view within its own coordinate system. You might think of the bounds as the local space of a view, and the frame as the world space. The origin point of the bounds in this example is at 0, 0. Also note that in this space, positive y is up. So why do we need both of these values attached to our views?
If we change the origin of the frame and move it down to 50-90, the whole image moves within that parent coordinate system. But the bounds origin doesn't change. That stays at 0, 0 because the view's local coordinate system moves along within the frame. If we change the origin of the bounds to -50, -40, the frame doesn't change at all. Instead, the contents of the view move up and to the left. This is essentially how a scroll view works. The contents of the scroll view move within its local coordinate space, while the scroll view's frame remains stationary in its parent space. With all of that theory behind us, we can try to build our own scroll view next.
Now you know the difference between the frame and bounds of a view. With that knowledge, we can create our own basic implementation of a scroll view. To do that, we'll need a gesture recognizer. If you followed along with gesture recognizers in iOS, you'll recall that a gesture recognizer allows us to respond to specific kinds of touches in iOS. There are many different types of gesture recognizers for gestures like pinching, tapping, or swiping. We'll be using a pan gesture because we want to continuously scroll the content of a view as the user pans their finger around.
Open the starter project and check out main.storyboard. We've already set up this view controller for you with a view full of pretty planets and space animals. Sadly, the images run off the bottom of the view and there's currently no way to scroll to see them all. We'll turn this view into our own DIY scroll view to add that functionality. First, we'll need a new custom class for our scroll view. Click File, New File, and select a Cocoa Touch class. Name it DIY Scroll View and make it a subclass of UI View. When a user moves their finger within the view, we want the scroll view to match that movement in the y-axis. As we said, we can use a pan gesture recognizer to track touches like that.
We'll add the gesture recognizer itself from Interface Builder in a minute, but we can start our work here by creating the method to handle panning. So create an IB action named handlePan, and give it a UIPan gesture recognizer as a parameter. To get scrolling action, we need to get the translation of the gesture recognizer. Use the translation method and pass in self. That tells us how far the user's finger is moved. To actually move the content inside of our scroll view, we need to change the origin of the view's bounds. The change in the bounds should exactly match the translation value. Remember, we are only panning in the y-axis, so subtract the translation's y value from the bound's origin's y coordinate. Finally, you should reset the translation on the gesture recognizer with the setTranslation method. Set that to 0 with cgPoint.0 so that the translations don't compound each time the user scrolls.
Now we're ready to hook everything up in Interface Builder. First, select the view you want to scroll, and in the Identity Inspector, set the class to the one you made, DIY Scroll View. Then open up the Object Library with Shift-Command-L, look for a pan gesture recognizer, and drag one onto your scroll view. Make sure you get the scroll view, not the stack view. This does all the work of adding the gesture recognizer to the view for you. You can check the Connections Inspector for the scroll view, and you should see the pan gesture recognizer there. The last step is hooking up the IB action. In the document outline, Control-click and drag from the gesture recognizer to the scroll view and select Handle Pan. And now you're ready to build and run.
Try dragging a finger, or in our case a mouse pointer, around and we have a working scroll view. If you've scrolled through any views at all in iOS, you'll immediately notice how clunky our DIY scroll view feels in comparison.
It seems especially jerky in the simulator. If you try building to a device, you'll get a smoother experience, but it's still no match for Apple's implementation. This was a great exercise to get you acquainted with the basic idea of how a scroll view works, but we recommend taking advantage of all that Apple's UI scroll view provides instead of trying to write your own. After the upcoming challenge, we'll show you how easy it is to get started with UI scroll view.
Are you ready for your first scroll view challenge? We've got a sample app for you that will let you adjust the frame and bounds of a view. By playing with this app, you'll get a better idea of how altering those two properties works in practice. The app contains sliders to change both properties. Your challenge is to write the code to actually adjust the frame and bounds with those sliders. All of the outlets and actions have been hooked up for you. All you have to do is write the code in the IB action methods. Pause the video and give it a shot, then come back to compare your solution with ours. How'd your challenge go? Well, if you had any trouble, Jesse will walk you through it now.
In the starter project in viewcontroller.swift, I know I need to add code in the IB action methods in place of all these to-dos. First, take a look at frame X slider changed. This is for the X value. To connect the view's frame to the slider, I set the origin of the frame X value to equal the frame X slider value. The frame X value expects a CG float, so I need to perform a conversion in order for this to work. For the bounds X slider changed method, I'll take similar action, this time setting the bounds origin X value instead of the frames. I'll do the same thing for frame Y slider changed and bounds Y slider changed. It's quickest to copy and paste the X-axis versions, then replace X's with Y's.
We're going to build this app to my phone because the simulator isn't running very smoothly right now. And we've got a neat little app here.
You can play around with these values and see exactly what happens when you change the origin values of the frame compared to the bounds. When you change the frame values, the whole view moves around within its super view.
I hid some animals in this scene for you to find. You can search for them by changing the bounds. When changing the bounds origin, you're moving the view's own local space, shifting the contents around along with it.
With this handy tool for understanding frames and bounds, you're ready to start using Apple's own UI scroll view in the next video.